Hi, how is it around there? Hope you guys are fine. As a method for finding roots of polynomials here under numerical method, we have seen different methods. We saw linear interpolation, and now we are going to look at graphical methods. Graphical method was one of them. So here, the roots of the equation can be obtained graphically, either using a single graph method or a two-graph method. Now, with a single graph method, we plot the function the way it appears. Then the value of x for which the curve crosses the x-axis is actually the root. In the illustration here, this is what we actually have, that if we plot our function like this, and where it crosses the x-axis, this is the x-axis, so at this point, this is where the root lies. So this is by using a single graph method. Now with the two graph method, the given function is split into two parts, i.e. we have y1 which is equal to fx, and y2 which is also equal to fx. Then the two parts are then plotted on the same graph. Then the value of x at which the two graphs meet is the root. Illustration: if y1 is a straight line and then y2 is a curve, wherever they meet at this point, that qualifies to be the root of our function. Let's have an example. Example here, using suitable graphs, find the approximate root of the equation. Now we are going to use both methods, the first method being a single graph method. Now with a single graph method, we are plotting this without splitting it. So the knowledge which we had in the O level about graph drawing here is very crucial, and you have to put in mind that the points where the curve crosses the x-axis, those points or those coordinates are actually giving us the root. So here we are going to, you can see that the range is not given. The range or the domain for values of x is not given. So what do? We pick on values in the neighborhood of 0, and that is assumed to have the root. Those values which are in the neighborhood of x are the values which are assumed to have the root. So here we are using try and error method. So that's the method which we are using here. So I picked on from -3 to +2, and when you substitute in here -3 squared, you get -3 squared, you get +9 times 2, that's 18, plus this is -9. So 18 minus 9, you get 9. 9 minus 3, we get this 6, and so on for these others here. Now, having come up with this table here, we now need to represent that on the graph. So here is our graph. Here is our graph. So we are going to plot these points here. These are the points which we are to plot. -3, 6. -3, 6 is here. -2, -1. -2, -1 is this point. -1, -4, this is the point. 0, 3, 0, -3, this is the point. 1, +2, 1, +2 is there. Then we have 2, 11. So this is our graph after joining through the points using your free hand and with a smooth curve. So this here is y being equal to 2x squared plus 3x minus 3. That's the equation. So at the points where our graph is cutting the x-axis, this here is the x-axis. So at the points where it crosses the x-axis, if you read very well at these points here, you are going to get here negative 2.2, and if you read very well this side, you're going to get 0.7. Of course, put in mind that you have to make a scale for this graph here. So this is when we use a single graph method. Now when it came to a two graph method, we said that we shall split the given equation. So the given equation is actually this here. This here is the given equation, this one here. So we have to split this equation here into two parts. That's the next procedure or the next steps that we have to take. So let's move down and see how we can do that. So here now, this is the equation, taking 3x minus 3 to the right hand side of the equal signs. This is what we have. So we took this, it is positive here, it will become a negative when it crosses. This will become a positive, that's why we have here this. And now dividing both sides by 2, we get this here. Now remember, we said that we shall come up with y1, which is equal to fx, and y2, which is also equal to fx. Remember, we said that we shall come up with the two equations. Now this side here, I'm going to let it to be y1, and this here I have let it to be y2. So this is y1 and this here is y2. Then after that, we are going to tabulate them like the way we tabulated this other one. Now we have to put in mind that the domain for the two graphs is still going to be the same. It's going to be the same. So here we are. I have picked on from -3, this is to +3, -3 to +3. So I have picked on the same domain. Okay, so when you happen to solve this at the values of the domain here, for example, take for example x being -3, put it here, -3 squared, you get +9. Then -2 squared, you get +4. -1 squared, you get +1, and so on. +3 squared, you get +9. So this here is for y1, which is equal to x squared. Now for y2, which is here, y2 is equal to 3 all over 2 minus 3 all over 2x. Now still we do the same thing, feeding in the values of the domain, and the values of our domain are ranging from -3 to +3. So substituting this there, we shall have here 6, we shall have here 4.5, like that up to the +3 this side. When substituted here, we are going to end up with, now these two tables are giving us the coordinates for each curve or for each graph. Now they are supposed to be plotted on the same graph, the same axis. Okay, so when you do that on the same axis, this is the graph that we come up with. That is the graph that we come up with there. So we first plotted y1, which is x squared, and this is the one. So when you -3, -9 there, you can see -2, 4 somewhere here. Yes, you can see that. -1, 1 here. We have 0, 0 there. 1, 1 here. We have 2, 4 there. We have 3, 9. This, when you join through using a smooth curve, using your free hand, this is the curve that we obtain. So this here is y1. We have also to plot for y2 because we say that the two of them have to be plotted on the same graph. So we plot this also. Negative 3, 6. Negative 3, 6 is there. We have negative 2, 4.5. Negative 2 is here and 4.5 is in the middle of 4 and 5. So a point is here. Then we have negative 1, 3. Negative 1, 3. This is the point. Then you have 0, 1.5. That point 0, 1.5 is here. And so on up to 3, negative 3. 3, negative 3. This here is the point. So we are done with plotting the two graphs, the two curves, the curve and the straight line on the same graph. Next, we are rid of the values which give us the root. The values of x where the two are meeting the curve and the straight line, those values of x qualify to be our root. So this is what we shall be doing here. We shall move down there and we rid of the values of x, and those values of x will qualify to be the root to our equations. So from here, if you happen to read very well, you can see this here is taking one small box there. We know that from here up to here has 5 smaller boxes, and this is a unit. So 1 divided by 5 we get 0.2. So that means one smaller box is 0.2. Up to here, this here is negative 2.2 there. Then here I'm seeing it is in the middle. It is in the middle. This is 3.5. Now 3.5 times what one smaller box represents, we shall get 0.7. So this is how we get the roots using graphical method. Let's have trial numbers. Trial questions are here. Trial questions are there. So let's try them out. Let us practice the knowledge that we have just received. Yes, number 1 is saying, using a suitable graph, find the approximate value of the roots of the equation that. Okay. Number 2, given that the equation x power 3 minus 2x plus 5, using graphical method, they want us to find the roots of the equation. Approximate roots. Then again, number 3, they are saying the equation sine x minus a half x is equal to 0. Using graphical method, find the approximate root of the equation in the interval. So here they have given us the interval, unlike the first two questions and this last one here. So for this case, you can see that we have a sine function in there. So when you're trying to find the values of sine, sine x, you will have to put your calculator in radian. Please remember from the lesson which we had about the trigonometrical functions. If you have not reviewed that video, please, if you have not viewed it, go and review. Okay. Then number 4 is here, plotting. By plotting accurate stable graphs, they want us to plot this and plot this. Later on, they want us to find this. Of course, this has to be plotted on the same graph, same piece of paper. So do that where they meet. So this where they meet, that will imply that exponential x is equal to 3 minus x. So when you bring this to this side, you shall have exponential x plus x minus 3 When you bring this side, giving us 0. So where they will be meeting, where the two graphs, this and that, will be meeting, we'll have to give the solution to this equation. So this is demanding us to look out for the points where the two are meeting. So thank you very much for being part of my audience, and I encourage you to share with your friends these videos, this link, and please subscribe with me such that you can be receiving more videos once I upload them. Once again, I want to thank you very much for being part of my audience.